Okay, so as we continue on with rational exponents and radicals, at this point in time, students are familiar or should be familiar with square roots and then the Pythagorean theorem. And we're going to extend that knowledge where we are going to be writing radical expressions with nth roots and something along the lines of an nth root, because it's going to be some future number and it's identified as n, so that is going to be my root. We're going to be converting these expressions from radical notation to exponential notation and vice versa. And we are going to take that previous knowledge and we're going to be able to relate it to, for example, when we found 16 to 1/4, that is actually going to be the example of the fourth root of 16, because we were looking for some number multiplied times itself 4 times that equals 16. Well, that's exactly what we're going to be doing here. We're looking for some number multiplied times itself 4 times that will equal 16. So extending beyond that square root, and the reason it's called a square root is because that would be the square root of 4, which we are looking for some number multiplied times itself, the square, that would equal 4, and that would be equal to the square root of 2 times 2, or 2. So extending that knowledge, and here we go. So what is the simplified form of each one of these expressions? So as we move forward, let's see. Definitions. Radical. Here we go. That is not a radical, but that is a radical. The number inside the radical is your radicand, and the number right here is going to be your index, just so you know. So we're looking at what is the simplified form of each expression without using a calculator. So what we're asking for here is we're looking for the third root of 125, which means we're looking for some number that we multiply times itself 3 times to get 125. So that would be the same thing as the third root of, let's think of those things, 5 times 5 times 5, and that is going to be equal to 125. So the third root of 125 is going to be 5. We multiply 5 times itself 3 times to get 125. Let's see, now I've already leaned forward and given you this next one, but we're looking for the fourth root of 16. So we could say that we're looking for the fourth root of 16, and if we didn't know it, we could say, well, that's 4 times 4, but it is also 2 times 2 times 2 times 2, thereby giving us the fourth root. Some number multiplied times itself 4 times to give me 16 is going to be 2. Okay, so looking at this next problem, we are looking for the third root of 27, and some of the factors of 27 might be 9 and 3, but that's not 3. But we do know the third root, well, we do have 3 times 3 times 3 is going to give me 27, so some number multiplied times itself 3 times to give me 27, well, that is going to be equal to 3. So continuing on, the fifth root of 32. Let's see, well, we know that 32 is going to be 16 times 2, which is also 8 times 2 times 2, which is also 4 times 2, which is 8 times 2 times 2. And then finally, 2 times 2 times 2 times 2 times 2 would give me 32. So I'm looking for that number multiplied times itself 5 times. It gives me 32. And sure enough, that is going to be 2. Continuing on with the cube root of 64. So we're looking for some number multiplied times itself 3 times. That will give me 64. And, well, depending on how you do this, well, I could say 4 times 4 times 4 is going to give me 64. and that would be then the cube root of 64 is 4. Now, stopping for a moment, looking at, we are dealing with the cube root and the square root here. Some things that all students should know by now, and if you don't, you just need to practice your math facts. You should know at this point in time that your perfect square roots, x squared is, you should know that the square roots, your perfect squares, your very important products, you have 1, 4, 9, 16, 25. Hopefully you see a pattern forming here. These very important products are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and continuing down. You should know up to, at this point in time, you should know up to 225, which is 15 squared, at this level of your education. And I would say that when it comes to your perfect cubes, you should know that 1 is 1 cubed. You should know that 8 is 2 cubed. You should have a couple of these also in your memory bank. 27 is 3 cubed. 64 is going to be 4 cubed. 125 is going to be 5 cubed. These you should have memorized, and of course you should know your multiplications of 10. That 1,000 is actually 10 cubed. So some of these very important products, or these perfect cubes and squares, you should be at a position to have them memorized or be working on them right now. Because when I come to E and D, or E and F as examples, you should be able to recognize the cube here. You should be able to recognize that what is the square root of 36, because you will often see this written as just the square root of 36. If there's no number there, it's intended to be the square. And we know that the square root, 36 is 6 times 6, so we know the square root is going to be 6. Now, moving on, side note there, but those are some things that you should know, and if you don't, you might want to start making points to study. Converting to radical form. Okay, here we go. I can rewrite this radical as we were looking at it. If I look at this very last one, 2 square root of 36, or the second root of 36, can be rewritten as 36 to the 1/2. Because right here you'll notice that 36 is to the power of 1, and then we're looking for the second root, and then that way we get 36 to the 1/2 power. And then if I were to convert that back to the radical, of course, I'm going to have 36, and then the 2 will come over and become the index of the radical. So that would become 1 and a 2. So we just convert it back and forth, and that's what this diagram is showing here, that a to the 1/n power is going to be the nth root of a to the first. So we're going to take these next, and we're going to convert them to radical form. So what is each exponential equation in radical form? All right, so this we're going to take, and we're going to bring that 6 down and put it into the index of the radical. So we're going to have the 6th root of a to the 5th. That is how you would convert that. The next one, well, got to be cautious here, because this fractional exponent goes to the variable, not to the number. So if we rewrite that to make it a little bit understood, here we have 5 times x to the 1/3. So we have 5 times the radical, and again, bringing the 3 around to the index, we are going to have to the cubed root of x to the 1st. Let's see here, continuing on. Now, since everything here is inside the parentheses, we know that this entire exponent goes to all of that. So then we would have what would be the third root, take that denominator and turn it into the index of 54y squared. And this is where some of those math facts are going to come into play that you need to be able to recognize. Okay, so I know that the cubed root of y squared, I can't do anything more with that because there's no 3's in there. There's no y's that multiply times itself 3 times because we only have 2 y's because it's squared. But we need to look at this 54. That's going to be 54 squared. So we have 54 squared. And I know that I'm breaking this down because I'm trying to show you some of my thinking, that 54 is 27 times 2 squared. Okay. Now I'm looking at 27. 27 is going to be a perfect cube. So again, some of the things that I'm thinking here, I have y squared and I haven't done anything with that. But if I go ahead and I'm going to distribute that 2 out, make everything squared, that's going to leave behind 27 times 27, because I have 2 of them, times 2 times 2. And there you have some perfect cubes. We know that 27 is a perfect cube, right? We know that this 27 is a perfect cube. So if I bring those out as perfect cubes, I know that 27, the cubed root of 27 is 3. I know the cubed root of this 27 is 3. So I can bring them out. I have 3 times 3 outside the radical, leaving inside the radical y squared and then 2 times 2, which is 4. And if I go ahead and rewrite that in the proper manner, I would have 9 times 4y squared. A lot of work there. However, in the end, it's little math, little math, little math, but it was a lot of steps for me to show you how it was broken down. And we will get more practice, but understand that, in the end, we are learning how to make factor trees and identify squares and cubes. And so let's see, moving forward, we have, to put this in radical form, we are going to have the radical, the 5th root, right, because that's going to come around here, of 64a to the 4th power. And we're looking for the 5th root. And if you recall, one of the most common 5th roots that you'll see is going to be this guy right here, right? The 5th root of 32, we said, was 2. So I am looking at here, I know that the 5th root of this stuff is going to be 64 to the 4th, a to the 4th. And I can't do anything with a to the 4th. That's going to remain just like it is because there is no 5th root because we only have 4 a's. But I can do something with this 64. And that is going to be, I am going to have the 5th root of 32 times 2 to the 4th, a to the 4th. All right, continuing on here. The 5th root, I'm going to go ahead and do my multiplication. I'm going to go ahead and distribute this out the 4 times that I'm going to be multiplying it times itself. So that is going to be 32 times 32 times 32 times 32. There's my 4. Times 8 to the 4th is going to be 16 times a to the 4th. And I know that the 5th root here, 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 and here is going to be 2. So I can bring those 2 out. So that is going to be 2 to the 4th, or 2 times 2 times 2 times 2, which is going to be 16, 5th root of 16a to the 4th, because, as I canceled those and brought those out. I know it's a little bit complicated, but it's going to take a little bit of practice. Now, as we go from radicals to the fractional exponent, or exponential form, we're going to do the same thing but in reverse. So we write each radical expression in exponential form. So again, my index is actually going to become my denominator. So I would rewrite this as x to the 2 over, sorry, I said x, as s to the 2 over 3. Or if I wanted to write it legibly, s to the 2 over 3, 2/3. And continuing on, so we have, we have 12 to the cubed root of x to the 4th. Now, if just in exponential form, I actually could have simplified that. Yeah, I could have simplified that, but they're not asking me to, so I want to make sure that I turn the index into the denominator. So we are going to have 12 times x to the 4 over 3, again, or just 12x to the 4/3. Continuing on, if there is no index, it's a square root, so we know that the index should be 2. So that becomes my denominator. So I should have here 4y, because it's all in parentheses, to the 5/2 power, and that is converting it to its exponential form. However, if I were to look at this, there are some things that I can realize that right here, I'm looking for the square root. And the square root of 4, even though 4 is raised to the 5th power, I know that I can find the square root of 4. So if I were to rewrite this, think about it in this term, or in this manner, I would have the square root of 4 times 4 times 4 times 4 times 4 times y to the 5th. Okay, and I know then, just from knowing the 4 is a perfect square that, well, that's 2, 2, 2, 2, 2. So technically, the square root of 4 to the 5th power is going to be 32. And then I'm going to have y to the 5th. Now, if I put that in radical form, then that is going to equal 32y to the 5/2. I'm just showing you that we actually could have simplified 4 to the 5/2, because it is a root. It can be simplified. So that is an answer there too. This is a better answer, a simplified answer, versus this, just because there are squares, perfect squares within 4, and we can remove the radical and the fraction. We did not do that here because we are leaving our x with just one exponent. And as we get more practice, this will make a little bit more sense. So again, making our index our denominator, we would have b to the 3/5 power. Now, again, here's another one of those where I'm looking for the cubed root of 27 and d to the 5th. Well, I know that there's a perfect cube root to 27. That is 3 times 3 times 3. So the cube root of 27 is actually going to be 3. And then we would have d to the 5/3. Now, using a radical expression, of course it wouldn't be algebra without a word problem, you can estimate the metabolic rate of living organisms based on the body mass using Kuyper's law. Now the formula, they've given us a formula where R is equal to 73.3 times the 4th root of m cubed. relates the metabolic rate of R measured in calories per day to body mass, and that's M is your body mass in kilograms. Now, what is the metabolic rate of a dog with a body mass of 18 kilograms? Well, all you're doing here, that's a whole bunch of stuff to tell me, hey, 18 kilograms, mass, M stands for mass, kilograms. Plug that in and tell me what my metabolic rate is, which they said metabolic rate equals R. So my metabolic rate is going to equal 73.3 to the fourth root of replacing M with 18 cubed. And what does that equal? Okay, so to go ahead and get that in the calculator, we can go ahead and type in 73.3. And that is going to be the beginning of my equation. And that's going to be multiplied times the fourth root of 18 cubed. And there's many ways to do this, but what I want to do is I'm going to go ahead and hit multiplication times. And now we're going to use this right here, which is allowing me to use any root. The calculator allows me to place in any root, so I'm going to use that. So if I come back, I see, so I have 73.3 times, and now since I want to use the fourth root, I'm going to go ahead and place a 4 in here now. So when I do math, option number 5, that is going to place that 4 into the root area for me. So there we go. I have 73.3 times the fourth root of, well, the fourth root is going to be of 18, and then raised to the third power, and then I just hit enter. And it's going to give me 640.557, or if we round that up, that's going to be 641. So 641, oops, 641, and let's see, which will be 641 what? Calories. There you go, 641 calories. And as we go ahead, we can do the next equation the same way, where we're looking for that same metabolic rate of a man now with a body mass of 75 kilograms. So that's going to be 73.3 to the fourth root of 75 now to the third power, which is going to give me a completely different value. So again, using your calculator. So there we have, it's going to be 1,868.09, rounding to the whole number, I guess, the whole calorie, we would be 1,868 calories per day. So there you have it, using the calculator to solve some of those roots, and this being one of those key tools that the calculator is going to allow us to do.